Okay, for this example here, finding increasing and decreasing this function, we have to first find critical numbers. So to find the critical numbers, we're going to find the derivative of g. And so when I have this scenario, I have to use quotient rule. So it's x squared minus x minus 6 squared times x squared minus 6 times the derivative of the top, which is 2x minus 1, minus the derivative of the bottom, which is 2x minus 1 times x squared minus x. Okay, and so I'm going to factor the top part. When I factor the top, I pull out a 2x minus 1, and I have x squared minus x minus 6 minus an x squared plus an x. And this is all over the derivative, or the denominator squared. Looking and seeing what cancels, I know that cancels this. This subtracts that away. And so I get this derivative simplifying to negative 6 2x minus 1 over x squared minus x minus 6 all squared. So to find the critical numbers now, I set the derivative equal to 0. When I do that, I get 2x minus 1 is 0, which tells me that x equals 1/2. Now, the denominator is not even defined at x equal to 3 and negative 2, I believe it is. So I only have one critical number is x equal to 1/2. If I want to find increasing and decreasing, I found the critical numbers, and now I need to make a number line looking at g prime of x and g of x, and I put the values where I have critical numbers. But I also have to put where the function is not defined. So if I look at my function here, I know that I can factor that to x minus 3 times x plus 2. Therefore, x equal to 3 and x equal to minus 2 are vertical asymptotes. The function is not defined here. It's not in the domain. I have to include those values, positive 3 and negative 2, and negative 2 on my number line. I know it can't be those, but I have to consider those. So now, looking at my derivative, and I can see my derivative is here. I choose a number to the left of negative 2, so like negative 10. The bottom is always positive. My bottom is always positive because it's squared. The top negative 10 will make this negative times a negative be a positive. So overall, this is positive, which means the function is increasing. Between negative 2.5, I'll choose the value 0. Again, it's positive on the bottom. That's negative. If that's 0, that's negative as well. So that's two positives. And again, this is, increasing because it is positive overall. And on this interval, I'll choose the value of 1. Again, it's positive on the denominator. I get a negative and a positive, which makes it negative. So overall, it is negative, therefore decreasing. And then larger than 3, again, the denominator is positive. The numerator, if this is positive 100, well, that's a positive and negative. So overall, it is a negative, which means it is decreasing. So if I want to find the intervals of increasing and decreasing, the function is not defined at negative 2. So I am going to say that from negative infinity less than x less than negative 2, and negative 2 less than x less than 1/2, and decreasing. Another way I could write this is I can say 1/2 less than x, 1/2 less than, let me try that again, x bigger than 1/2, but x cannot be 3. That will include this interval as well. So just to recap, find the derivative, set it equal to 0, state the critical numbers, make a number line with critical numbers and the restrictions on the domain, find positive and negatives for the derivative, hence increase and decreasing for the function.